In today's lesson, we're looking at sketching curves that have undifferentiable sections. Now, I want you to cast your mind right back to when we first learned how to differentiate, because at the end of that unit, we had a whole lesson on finding sections of curve that would be undifferentiable. And remember, we already saw that we couldn't differentiate curves where there was a vertical asymptote or some other discontinuity in x. So we've already seen that. And we couldn't differentiate a curve where there was a sharp point. Now, the reason's pretty obvious when there's a discontinuity in x. If there is no curve there for some value of x, there is no y value, then you can't say, hey, what's the gradient of the curve right there? Because if there's no curve, it has no gradient, right? But this one also made sense because remember, our whole understanding of differentiation is that we were approximating the gradient of a curve. And our method for doing that when we looked at first principles was actually to look at the gradient of a secant, 2 points on the curve, and then reason that as they got closer and closer together, they would approximate the gradient of the actual curve better and better. Now, to do that, we're relying on the curve moving with some predictability. So if it's going to have a sharp corner, and the gradient at one point is quite different from the gradient at the point right beside it, then that whole idea falls down. So we can't differentiate a curve in and around those sharp points or at the sharp points. The other thing that we have considered, but maybe not so formally yet, because we haven't had to graph many curves that have vertical sections, is that a vertical section of curve has no gradient. It doesn't have a gradient of 0, remember that's a horizontal section. A vertical section has undefined gradient. Now, if the gradient is not defined, what we need to reason is that y dash will not be defined. Okay, so that's what we've written here. Curves cannot be differentiated, and therefore y dash will be undefined at any of these places. Now, we're good at differentiating now. We're good at finding the formula for y dash when we're given the formula for y, or for the curve itself. So we need to be able to spot these things by looking at the formulas. Now, one thing to keep in mind is that it's quite straightforward, I think, to say, look, if y is undefined, in other words, if there is no curve in a particular section for some value of x, then obviously, how can we find y dash if y doesn't exist? Now, this is what's happening in this sort of case. If we have a hyperbola, let's just look at the most basic one, something like y equals 1 over x, then we can see that when x equals 0, there's no curve right there. So when we say, hey, what's the gradient of the curve when x equals 0, we can't find it because there's no curve there to look at the steepness of. So to me, that one makes a whole lot of sense. When y is undefined, in other words, if there is no graph, then y dash is obviously going to be undefined. I think that one's simple. But these 2 points here remind us to keep something else in mind, which is that y can be defined while y dash is undefined. Now, what's happening there is that if we have a vertical section or a sharp point, we've got a section of graph. We've got a y value. Y exists for that value of x, but y dash has no real meaning, and so we're going to say that it's undefined. Now, in the rest of this video, I'd like to show you an example of a curve that has each of these points, and one, in fact, that has 2 of them. So I'm going to put in some examples here. I'll just use red to jot them in, and then I'll show you each one on its own, and we'll have a look at how to graph it. So something that has a vertical asymptote, let's graph something like y equals 1 over x squared minus 4x. Something that has sharp points that we might not have thought about graphing for a while, let's graph an absolute value. How about something like this? And something that has vertical sections, let's graph y equals the cubed root of x. And then something that has both of these, let's graph y equals x to the power of 2/3. Okay, so I'm going to graph each of these 4 curves now, and we'll have a look at how to do that. If you're looking at it and thinking, gee, what's the shape here, and what am I going to do? What do I need to look out for? And why exactly is y dash undefined? So that then we're not tripped up by any of these sorts of curves.